Hey, this is Joe at Graybench Electronics. Today we're going to rebuild this Prescription Electronics Experience Fuzz. Alright, so if you are wondering why I have this enclosure, why it's empty, I did do a previous video on this lot of stuff from Prescription Electronics that I bought off eBay. You can see a link for that in the corner right there. But basically I found this lot on eBay for a bunch of stuff from Jack Brossart's estate sale. Jack Brossart was the owner and proprietor of Prescription Electronics out of Portland, and unfortunately he did pass away in 2019. But I saw this and I thought this would be a cool project for the channel, and it would be a nice thing to bring this pedal back to working condition, because obviously there aren't going to be any new ones being made. It's a standard Experience pedal. Obviously it looks like it's been built in before. There's definitely indication of that. There's also a decent amount of wear to the paint. It looks like there's actually multiple finishes that have been applied. There is this red outer powder coat, obviously, but there's also this inner, it's a textured, almost looks like stone coating of some sort. Not sure what that is. And then underneath appears to be another layer of red. I'm not sure why or what the plan was there, but that's what I see. Obviously we had the Experience silkscreen graphics, standard volume tone sustained swell, fuzz octave swell switches, input and output jacks, mounting holes for a 9-volt battery clip, which I don't have. We're going to have to figure out where to get that. DC jack input, and that is it. Let's go ahead and crack it open here. Alright, so here is the inside. You see there, it is a Hammond enclosure, 1590C, which is sort of like the face of a 1590B, but really deep. So obviously we're going to need all the parts to build this pedal: potentiometers, foot switches, input jacks, DC jack. I do have, the seller from the eBay listing was nice enough to send me some extra knobs, and I actually have 4 of these, not knurled, but they're there's a like piping on the side for grip. And I've seen pictures of Experience pedals that have these knobs on them. So these are the actual knobs you would have got from Prescription Electronics if you had bought an Experience. I also, for this project, finally dipped my toes into making a PCB. So that is what I have here. I actually designed this PCB myself. I'm kind of proud of it. It's my first design ever. Probably could have gone with something slightly simpler for a first design. Usually people start with like a 555 timer LED blinker thing. I decided to go with a pedal that's like 4 discrete transistor stages with internals or like inline switching. Not the easiest project to start with, and it did take me several hours and several retries to get it. But I think I've got something that will work here. I did design it to be mounted around this fuzz foot switch, which is this foot switch here. So it's going to sit on top of the fuzz. Grab those foot switches. So it's one of these PCB mount with the solder pins, and that's going to go into the fuzz hole there, and then the board is going to sit on top of it like that, and that's how it's going to stand inside. I'm thinking it's going to be fine, sort of cantilevered out like that. It's not like PCBs and electronic components are heavy, so I think that should be fine. It will also partially be sitting on top of the second foot switch here, which is the octave switch. So we're just going to have to make sure there's clearance for that. We don't want anything shorting out. The octave switch is only it's only a single pole, single throw, just kind of bringing in that one side of the rectification. And so I had this same style solder pin foot switch, but one of the legs had broken off already. So I just removed the other 2 and made sure it's nice and flush with the body, so that the PC board can sort of sit above that and not risk shorting anything out. So that's going to be in that bottom hole, and then the PCB is going to sit above it. So that's the plan. We're going to start assembling some components. Actually, we're going to build the PCB first, and then we'll continue on with the build after that. Alright, got the PCB all populated here. Obviously those transistor legs are being left long for the time being, just while we're in the testing phase. This would be a good time if you're building a pedal to hook up some wires, potentiometers, and try it out before you do what I'm going to do, which is put in the enclosure. I'm playing it a little risky by going ahead and soldering it into the foot switch. It's interesting, there's a fourth wall breaking effect because I don't know if this is going to work. It's my first design ever. Very likely, or at least very possible, that I've made a mistake somewhere. In fact, I already know I got the naming, the emitter base collector naming on the transistors, that's backwards. The silk screen, the shape of the transistor is correct, but I put a little EBC on there just to help figure it out, which legs are which, just by looking at it, and I got that backwards. But I could have made a more severe mistake that will actually affect the pedal function. I don't know yet, but you do, because if you are seeing this video right now, it must have worked. Anyway, we're going to drop this in here. So I've got a little piece of poster tack sitting in there just to help me level out the board. And I've got it just about where I want it, just so the board's sitting pretty straight. I'm not going to get it perfect here just because of the way this is sitting. But the idea is to get it down on the PCB, or get it down on the foot switch, and it's sort of resting on the inside, the second pole of that octave switch. You only need the one pole. In fact, you only need half of it for the octave switch. That little piece of post jack, that's going to come out of there. I'm just trying to use that to line it up and support it while I solder in the foot switch. Okay, so now the board is locked into the foot switch, and if we want to get it out, we just have to take out the foot switch itself. And yeah, that's the 6 points of contact I would have no problem with this sitting like that. It's really not a big deal at all. Okay, so that drops in there. That's just going to float right on top of there like that. So next step, we're going to hook up some wires. We have to connect to the input and output switches to the board here. Connect the potentiometers to the matching spots here. And we're going to wire in the switch to the switch contacts, which is the OCT. Little holes right there. And plus or minus, we're just going to hook the DC jack up directly to that. Actually, we're going to put in a battery snap, but also wire in the DC jack, and there's wiring available for that if you're unsure. The swell is hooked up after the output of the swell goes to the switch, and then there's a fairly complicated wiring scheme. I'll put a link to a drawing by someone else that I'm using essentially for this pedal. So let's get started on that. So one mistake I'm realizing I've made looking at the wire diagram, I was thinking the octave switch, because it's just the single pole switching the octave in and out, I was thinking that's all the octave switch is, but no, I forgot the switching scheme is really complicated, and it uses that second pole of the octave switch for part of the swell bypassing and whatnot. So this switch unfortunately is not going to work because I've already removed that pole in order to clear the board that sits on top of it. But then I remembered, oh yeah, these solder lug ones are the same height, but the lugs come out to the side, so there's still clearance on top. So I think what I can do is I can use one of the solder lug ones, which are easier to solder to anyway, and it'll still clear the board and give that sort of platform for the board, not that it's super necessary. And I'll have the second pole available for the switching scheme. So I'm going to use this for the octave switch instead of the one I showed previously with half the lugs removed. All right, here is the Prescription Electronics Experience all rebuilt with the PCB that I made for it. I did find a couple errors. The one I already talked about, the transistor markings, the pinout I had backwards, so I've written on there EBC, but it should be CBE. The other mistake I saw was this capacitor here, which is C13, that was reversed, so I had to install it with the opposite polarity than what the silk screen indicated. Other than that, I did previously install the 3904 transistors. However, I remembered I had a small handful of 3565 transistors that were used but still functional, and those are a good choice for this because that was the transistor that was originally used for the Fox Toe machine, which is what the Experience is based on. So I popped those in there, and you know, they look cool. They're kind of an interesting visual thing. You don't often see these black dome transistors in much, unlike the 3904s, which is the 292 package, much more common. Probably it's not going to sound any different at all, at least not discernible or something that you could pin specifically to the transistor, but we're making a pedal to bring back. It's a vintage pedal based on a vintage design, so it can't hurt to use original components. As far as germanium transistors, I have those installed. Of course, these are the D9Ks, the Soviet D9Ks. The two here that are the same polarity, these are the rectifier diodes for the octave circuit. The back-to-back diodes here are the clipping diodes. And it should be clarified that the clipping diodes in this case, they do add a bit of distortion, which is true, but they're also for controlling the volume, which helps with the octave effect and lets that that double frequency shine through more than if you had other clipping diodes, even higher threshold clipping diodes. So germanium is definitely important for that position. Other than that, I think we're ready to give this a try. So let me set up the amp and microphone and we'll have a listen, hopefully. All right, got the pedal all ready to test here. So this is gonna be the first time I'm trying it. Y'all are right here with me. So as far as setup, I've got a Fender Stratocaster on the bridge pickup. I've got a Bassman, modded Bassman sort of thing, SM57, straight on axis, right on the dust cover. And what else? Assuming everything works, when we try the octave setting, I am going to switch to the neck pickup because the neck pickup has less of those extra harmonics that don't work well for octave pedals. So I guess nothing left to do except just put our knobs at noon and see what happens. Here we go. Here's a clean tone. And fuzz tone. It lives. Little volume discrepancy there. Turn that up. It's a little woofy. Gonna push the tone knob up. That's better. Yeah, sounds nice. Sustain up. All right, let's try the octave. This is still bridge pickup. Oh yeah, wow. Let's go bridge pickup. Yeah, very strong octave effect, which is typical for the Fox toe machine. It's always had a very pronounced octave. Gets very woofy down here. Bring that back up. Yeah, it sounds nice. And let's try the swell. Now, experience pedal, notorious for the swell control not working, and there is a couple explanations for why that is. I'd like to do a whole video on explaining, you know, how this circuit is based off a misprinted circuit in an old electronics magazine. It's a story for another video maybe. But yeah, the swell circuit, it's an oddball thing that at best only sometimes works. So I don't have super high hopes. But for it to work, you do have to have the octave engaged. So now the octave is on. So let's hit the swell in. So what should happen is when I play, you should hear nothing, and then it should swell volume into coming out of the pedal. The volume should swell up. And that's definitely not what's happening. It's like it wants to work. You can hear it's doing something, but it's not working right. And like I said, the swell circuit in this, it's based off a mistake in an old electronics magazine, and it requires a certain guitar, it actually requires a certain amplifier input stage to make it work, because it misbiases the tube stage. It's an explanation, like I said, a story. So overall, I'm very pleased. I'm not super concerned. I know the swell control is supposed to not work, quote unquote supposed to. At least that's a reasonable expectation for the experience. But the fuzz and the octave is working great. And that's the bridge pickup too. And usually you can't really hear the octave on the bridge pickup, but it just goes to show how strong it is in this circuit. Lots of gain. I would say that's a pretty big success on the rebuild of the Prescription Electronics Experience. Well, I don't think I can ask for much more than that. The fuzz worked right off the bat. Octave up effect is very strong, and which isn't always the case for analog octave ups. You know, like the green ringer. It's sometimes it's pretty subtle, but definitely not the case in this pedal, as you heard. I'm pretty proud of the PCB. It was my first design, so the fact that it worked at all, I already consider myself pretty lucky. Speaking of which, I want to give a shout out to the YouTube channel Effects Layouts. They have a series on making DIY guitar pedals with Eagle, and those videos, as well as the library of components that they have on their video series, were indispensable in making this. So I'll link their YouTube channel in the description. Go check them out if you have any interest in making DIY guitar pedal PCBs, or just go check them out anyway and subscribe. Pretty happy this one's back in action. You know, it was a pleasure to rebuild this pedal, bring it back in commission. Unfortunately, lost one of the original boutiquers in Jack Brossart, but at least I could get this pedal going again. So I suppose it's time to sign. Still got to get the 9-volt battery holder, but close enough. All right, we'll button this thing up. Well, there we go. Prescription Electronics Experience. So one side thing, when you order PCBs, you order at least like 5 or so, because it doesn't make sense to only just make one. However, for some reason, they sent me like 15 of these things, and obviously I don't need them. So if you're interested and want to build a experience of your own, and are willing to take on like the having to use the double pull, double throw with the PC pin, foot switch and whatnot, then I will have these PCBs available. I'm going to sell them for like $5 a piece with $3 shipping or so. They'll be on my Reaper store. I'll put a link in the description, and I'll have a bill of materials and a schematic there if you want to check that out. But these are being sold as is. You know, I can't be like helping you tech support and whatnot. You're on your own if you want to build this, but I'll give you that stuff, and if you're interested, you know, go buy it. And it's going to be one per person on these, because there's only, I think, 14, I guess, now. So, all right, that's a wrap on rebuilding this Prescription Electronics Experience. I am super happy that it is back in working condition. If you enjoyed the video, I'd appreciate you hitting the like button and subscribing, and hit the notification bell if you want to know when I make a new video. I'm Joe from Graybench Electronics. Thanks for watching.